minus 3 squared, you'd already get 0, and then anything beyond that will give you 0. So, but like I say, in these equations, the differential equations that I showed you on Monday, you want to keep the order down because you're going to have to, when you find your y sub p in the differential equations, you have to keep taking its derivative. So that's why you want to do the smallest order for the annihilators in general. So anyway, on your test, if I ask you for a differential operator and then an annihilator, then I'll say of the smallest order, meaning that pick the power that's the least that you need to annihilate a function. So the text used to say that. I don't know why he dropped that out of there, because you don't want people to use a bigger order than you need. So that annihilates, let's see, the given function. So here I wanted to do a different type that I haven't done yet. And so here's a trig example. So this is right here. Okay, here we go. Okay, and so say you had 7e
Trying to compete with me.
x cosine 2x, and then minus 3x e to the minus x cosine 2x. So the difference between those two is that this has an x in it, okay, and then plus, and then x squared e to the minus x sine 2x, like that. And so the trig functions are of the type where the coefficient on the x and the exponent on e is minus 1, and the argument, the x, 2x argument has 2 in front of the x. So here, by looking at it, you think alpha is equal to minus 1 and beta is equal to 2. And so you're working with the complex number and its conjugate that is this form. And so in that table that I gave you, I showed you, in order to find the annihilator, so the annihilator is, because they're all the same kind, where you have a minus 1 up here and a 2 there, because this is an x squared, you're going to need to have your annihilator have a cube on it. And so the annihilator is going to look like this. So it's d, then it looks like d, let's see, where shall I put my parentheses? D, and then it's minus 1 plus 2i, and then there's that one, and then d minus, and then minus 1 minus 2i, and then you're going to need to cube, I think I wrote it like this in the table. So you want this cubed and you want that cubed. So because of this x squared, so you have to go up 1. So let me make sure I got enough parentheses. So this one matches that one, and this one matches that one, and this matches that. Yeah, that looks okay. So now, but you write your answer without complex numbers in it. So write your answer. Write your answer with real coefficients, with only real coefficients, rather than complex coefficients. So then, what I wanted to show you was the easiest way to do this kind of problem. So in the book, they just have you memorize some formula and then you cube it. But a lot of times when people just memorize that formula, they don't get the terms right. If you do it this way, it's foolproof. So, so I'm going to have this product, and it's all going to be cubed. So I just put a 3 on the outside, and then you write the things inside as it's d plus 1, and then minus 2i. So if you group it like this, and then it's d plus 1, and then plus 2i, like that. Those are your two factors. And And then, because when you take A minus B times, oh, let me not use A's and B's, let's use M's and N's. When you do M minus N times M plus N, that's the factorization for the difference of two squares. So when I multiply these things together, if I group the terms, you don't want to take these triples and multiply them together. You want to, because they're special, they're conjugate pairs that you're working with here. These are conjugate pairs. So when you multiply these things together, it's going to work out so that you get real number coefficients on your polynomial. So you might as well do it the most efficient way. So this is like the m minus n, and this is the m plus n. And so you're going to get m squared minus n squared. So you get d plus 1, the quantity squared. You don't have to multiply through triples. and then you'll get minus, and then you'll have the 2i squared. It's the m squared minus n squared. And then you multiply, and then this is just a perfect square, so you get d squared plus 2d plus 1. And then this one is going to be minus, and then it's going to be 4i squared, and I squared is minus 1, so you're going to get a plus 4 there. So it's all raised to the third power. There's a little 3 there. So raised to the third power, and so it's d squared plus 2d plus 5 cubed. So that's the way you would write the annihilator for those terms. Okay, so that's the easiest way to do it. Okay, and then, like I said, that corresponds to the differential equation. So, you know,
My phone's
so
better,
you'd have an auxiliary equation that looked like m squared plus 2m plus 5 cubed, and then it would be a sixth order differential equation that would be that this would be a solution for. So it's similar to the other one that I showed you. That's what that means. So now that is let's see, that's 15 through 26 all are like that, and then also you'll use for those problems also use that thing I showed you that when you have a sum of, see, like if I had put e to the 3x cosine 5x, then I'd have to do another one of these quadratics to get that term canceled out or annihilated. So you also use that fact that I told you that the sum, the product of two annihilators annihilates a sum. So also use that when you take L1 and L2 acting on Z plus W, you take the product of the annihilators. So the product, if L1 of Z equals 0 and L2 of W equals 0, then you take the product of the two annihilators to annihilate a sum. So also use that fact that I gave you in the notes in those problems there. You'll probably need it. And then for 27 through...
So sometimes if we can factor